record that. But so Troy is back at the conference. I say back because Troy Ader is a professor at Lehigh in the College of Business. Data is his name. Something is his game. I don't know what else we could put to that. And he was with us 3 years ago when we had our first conference on campus. And so he's gonna lighten the mood, I guess, a little bit. We're not going to go too much into great thought experiments, especially after what Guraj put us through, which was most interesting. He's going to a little bit more mundane, I guess, but still as important as to, okay, so what is it that we're doing here? Is it data analytics? Is it, what is it? So, Troy, please take it away.
I will. Let me go ahead and switch over. I've got a set of, it says host disabled, so I don't know that I am the host right now.
Hold on.
Or the co-host.
Just make him host again.
I gotta make you host again for some reason. Give me a second.
No idea why they threw you out.
I think that's the story of my life.
Make co-host.
Yeah.
Boom. That's it. You should be good now.
Okay, cool. And let's see here. So I'm sharing. And can everybody see my slides? Okay.
Yeah.
Okay, everybody. So thanks for having me. This presentation, as Patrick was saying, is, I don't know if I'd call it mundane, but it's certainly going to be a couple of levels below some of the talks we've had before. But I think it's an important topic to bring up. And it actually grew out of both a podcast that Patrick and I did a couple of months ago, and every elevator conversation I've had over the past 5 years, which is, so what is the difference between fintech and data analytics? More importantly, what do those differences, and first of all, that first part's an important question, because to be honest, it's like feeling, the old fable of blind men feeling the elephant. To some people, it's the tail, to some people, it's the trunk, and to some people, it's that big, thick leg. But more importantly, what's the implications for the differences between the two in terms of both what employers can expect to get out of an educational degree and what students are going to sort of be pathed through, if you will, in terms of getting a knowledge base. And then finally, are we doing it right, and are there ways to improve it? So in the course of my presentation, like I said, first of all, we're going to talk about what the difference between fintech and data analytics is. This is definitely my concept, and I'm open to anybody that wants to broaden my mind and give me some other different way of thinking about it. Because of those differences, and because of a certain inherent built-in focus that particularly undergraduate educational programs are going to have towards the analytics side, but also a lot of the master's programs too. What does that mean you can expect a student coming out of a degree program such as the ones we have at Lehigh? What kind of skill sets can you expect them to have? And is it what we need? What's the problems with that? How can we fix it? Now, a little bit of background about myself. I am a hybrid animal. I was a computer programmer. I went in the military for a while, got out, got my PhD in finance. Most importantly, though, if you look at the sort of 3 degree programs that I'm primarily associated with here at Lehigh, I'm the co-director for the CSB program. That's computer science and business. Students get accredited backgrounds in both business and computer science, making them ideally suited for some of the things we're going to talk about in terms of fintech and analytics. I'm also the co-director of the fintech minor in the business school, which, as we'll see, has a particular niche skill set that we both need to get into the students and that we need to send out them with to the workforce. And then finally, one of the reasons I was hired, I think I've been here 4 years now, was to actually start putting some business analytics into the entire undergraduate business curriculum. So we have required courses that those students take. And why is it analytics? Why isn't it fintech? And why did we choose the languages that we chose, and so forth? So to get started answering our questions, and you'll see where all of my background sort of comes into play here, let's look at, if you went into a current textbook or a current working paper on what the life cycle for that analytics revolves around in versus the life cycle that fintech, or I'm going to use AI in particular in fintech, revolves around, you'd see a couple of marked difference. Now, the steps for the core of both are going to be the same. You got to get data, clean data, store data, analyze the data, and then send out a report. In a business setting, you also have to think progressively about how you archive your data for reuse to send it back through the process again. Now, if you and this is from a recent paper in 2021 about what the AI lifecycle model is. If you put this up beside it, you can see that first, it's much more complicated. Secondly, those of you that are involved in AI or any other fintech, it seems to be, and I use this word sparingly, I don't want to put a negative connotation on it, but one would argue that the fintech development and use process is a little bit more frantic than the data analytics lifecycle. Put bluntly, the data analytics lifecycle could best be described as stately, like a ocean liner steaming through the ocean steadily but slowly and plugging along. More importantly is the speed involved. Normally, when we're talking about data analytics, and the key here is going to be sort of what the output of that process is. But normally when we're talking about data analytics, you're constructing something that you're going to give to a human to act on. Nowhere in this process, you might come up with models, you might tweak your models. There's certainly going to be feedback loops in this model in terms of once you start your analysis, you realize you need different data or you need them to be cleaned or curated in a different manner. But nowhere in this process are you actually making a decision. Decision making happens, in a sense, outside the loop. Once you get your visualization and or your report, you send it out to a manager or somebody that's responsible for acting upon it. Whereas if you think about it with the typical fintech model, such as we see here for AI, first, it's a lot more articulated. There's a lot more steps. And one could argue, well, that's because over here, you're talking about, a lot of times, maybe this is a nonprofit or maybe it's even academic doing this, and this is an academic view. But really, it's not much more, analytics isn't much more complicated even in a business setting. Unless, like you're doing over here, you're doing some of the same steps, but you have to be much more careful for two reasons. Sometimes it's because of your environment. Sometimes your environment requires, for instance, in fintech, a lot of times we're constantly assessing the risk of actions that we're going to propose out of a process. But more importantly, remember, the output product here isn't going to be just a report or a visualization. Ideally, it's going to be a computer model. And the key part, and what I think sort of drives the fundamental difference between the study of analytics and the study of things like fintech, which is spread to other disciplines like insurtech and so forth, is that analytics, you're producing something for a human to act on. In AI, fintech, you're producing a model where you're going to have the computer either act on the behalf of the human or at least do most of the heavy lifting for the human and then send out some notification, hey, this changed, or this has been updated, or the credit limit is now approaching on the deals with this counterparty. And so one of the reasons that you see a lot more sort of iterative and sort of feedback loops in the AI model is that you're making something that you depend on doing stuff for you. You're making an independent entity that you depend on doing stuff for you. And because of that, you got to get it right before you launch that thing out into the real world, where any mistakes it makes, any decisions it makes that you never envisioned it being in a particular environment, you gotta sort of war game before you get there, and you've got to plan those things out. So because of that, right, because analytics gives stuff to humans to act on, and fintech and its components basically involve building tools that will then act on the human's behalf in many cases, you wind up with sort of a spectrum. And going back a second, I'm not saying that, it's as simple as this, that analytics is always that simple and fintech AI is always this complicated. A lot of times you'll see something that's a big analytics project, but again, in the end, it produces something that the human looks at and decides on. Back in 2018, and I'm going to use this as an example of why I say that you're often giving a computer system the responsibility of acting on the human's behalf with fintech. Back in 2018, I gave a talk to Lehigh alumni, and one of the questions is, what is fintech? Obviously, there's a lot of, you can't do cryptocurrency hashing or anything along those lines without a lot of computational power. So I'm just going to skip over that. But if you think of and I'm going to use Patrick's word here again, the more mundane uses of fintech, automating and digitizing anti-money laundering, using in-car monitoring devices and wearable activity trackers, open banking, which often involves near constant financial information sharing between lenders and borrowers, which enables the lenders to better fine-tune their risk assessment and what they charge the borrower and so forth. Now, going back to actually something that Hank said before, the whole idea really that sort of ties the things that I've got highlighted in blue here together is that you're asking, they all involve doing something too many times or too quickly for a human to do for you, right? There's no way that we could actually do real-time financial monitoring between borrowers and lenders if we had a human that actually had to actively check on it. It would fall back to, the way we've got financial reports. It would be like a quarterly thing, or at best, or something along those lines. Same thing if you think about in-car monitoring devices. You've got a computer someplace that's monitoring that driver's activity and sending that data back, but it's monitoring it in real time whenever the car's on. So this whole idea that you really, when you boil down fintech, you're talking about enabling computers to act on our behalf. A lot of times when I tell people this, I end with a joke. For those of you that are old enough to remember the Terminator movies, I'm not worried about Cyberdyne, the company that created the first Terminator, arising out of the analytics field. And I'm not really worried, but there is a possibility that the first Terminator, if it does come, is going to come out of some instance where we've made a set of software that's supposed to act on our behalf, and we didn't think it through. Now, this is illustrated. Another slide that I show in a lot of my classes is sort of the spectrum of different data science. And I'm using data science as an umbrella term here to encompass both data analytics, business analytics, and fintech and other such topics. The spectrum varies on several attributes that we'll talk about in more detail. But as we're going to see in just a second, by its nature, analytics tends to live on the left-hand side of these, and Stata is just one choice of a proprietary software package that does stats for you. Stata and R on the left-hand side, and then Python, and has always been noted, C++, especially if you want speed, over on the sort of fintech side. And if you go down through these different sort of attributes, the reason that they matter, and let me move my video monitoring thing out of the way, slant refers to sort of what environment it's operating in, what kind of use cases, and a lot of times that's dictated by, do you want to do something fast but thorough, where you're going to let the computer act on your behalf, or is it a human, not just a human that you're giving the report to, but a human that's actually overseeing the analysis and looking and saying, oh, well, maybe this quarter, this year, we shouldn't be using that type of regression. We need to go back and change it, or something along those lines. Another important question, and a lot of times people, they don't realize this, and they start maybe doing fintech and they look at using Python or something along those lines. There's a reason that a lot of firms out there actually use Microsoft proprietary compilers, for example, in C++ in order to do their fintech. It's not just because C++ is faster, but you also get a more locked down environment. You don't have to worry about, a couple of years ago, in the middle of the year, R changed the random number generator. And if you were using something like a random number generator, that would be a bad thing. So open source has both benefits and disadvantages. Proprietary has benefits and disadvantages, but by and large, open source is more the wild, wild west, and proprietary software tends to be more locked down, obviously provided by one entity, and that one entity not only provides support, but it also updates supplemental packages. So the upside of things over on the open source side, we're talking about there's constant innovation. And what was the old joke meme that went around about a couple of decades ago? It used to be there's an app for that when smartphones first came around. Well, if there's something you want to do in R or even in Python, there's a package for that. Are there packages in C++? Yes, but they're in some sense, they're not as widely available, and sometimes they're proprietary, just like the core software. As has already been mentioned by Hank and others, as you move to the right of that spectrum, you're talking about a lot faster execution. And if you go back and look at the table, I actually detailed out that's because of sort of the level of interpretation versus compilation. Quite honestly, Python is bytecode compiled. It's not fully compiled the way that C++ is. So if you really want speed, you got to move to the right of the spectrum. The other thing, and I actually thought about this a lot when I designed our undergrad analytics program, is the sort of ubiquity of the interface and the usefulness of the interface. Long story short, R has RStudio. Are there others? Yes. I would say over 90% of users for R use RStudio. When you go over to the Python and C++ side of the world, though, there's a lot more variety there. So I guess part of the answer to the next question, which is, what are we teaching? Why are we teaching it? And how does it fit into this spectrum and all these other things? Is, well, you get some commonality with R. You get some commonality using RStudio. Makes it easier to teach. And if you try to do Python or something, different instructors, even different students in a particular class are going to deviate. One will use Spider, one will use Eclipse, and so forth. There's also another subtle reason. Over on that right-hand side of the spectrum, if you're going to have a computer doing something constantly, it's not going to be running on somebody's laptop or somebody's desktop. You're probably going to launch a cloud-based server. And that server you want it to be as fast as possible. You don't want to slow it down with overhead like a graphic user interface OS. So a lot of times it's running Linux command line. And so what's the bed of resources, if you will, to help people leverage what they might develop in an IDE, whether it's on the right or left-hand side of the spectrum, but for an environment in which it's going to be running constantly on a very sort of low footprint server, you're better to be over on the right-hand side of the spectrum, because Python and C++ actual code runs on the command line. So, and I'm going to you could do this with a graduate education. I'm going to do it with the undergraduate education. How do we see this difference between analytics and fintech sort of playing out? Well, to be quite honest, when you design a business curriculum like we did here, and if you're going to do analytics, every one of our undergraduate classes uses R except for the database class, BIS 324. So part of the reason that I chose R for this class, and this class is because we were already heavily using R. We lucked out. To be quite honest, many other universities are not using, and that goes over to the 400 level of those classes used in many master's programs too. But many universities are not using R at the analytics portion of their life cycle. And so that means they've got a lot less of a sort of clear path through adopting, learning, using, and teaching a particular package.
Troy,
Yes.
One question for you. One thing I noticed is that so we have projects in our program, and a lot of in fact, if not most, all of them use Python. And I say projects, not to do with the course per se, the curriculum per se, but really the projects that are guided by the corporate sponsors. So it would appear that out there, people are using Python. I mean, maybe they're not using exactly the same thing that you're teaching, but so if you're a student, what do? You learn R, you learn Python besides?
So the answer to both questions is probably yes. But let me show the next slide, because I was actually going to use the MSFE as an example. Or sorry, let me skip over this one and go to this one, and I'll come back and talk about why we chose R. So if you go back and look at that AI lifecycle, you're right. Python in real-world implementations makes a lot more sense. And you'll sort of, it's not just that you use Python, but the whole body of knowledge that you need to do these kinds of things is going to be drawn from a wide variety of sources. If you just look at the courses that, we have students taking in the MSFE, you're taking calculus, you're taking the stats course, you're taking finance courses, industrial engineering. More importantly, a lot of these are science-based or math-based, and Python's more common over there. So let me go back and talk about sort of why we chose R, and then let's talk about the elephant in the room, which is, doesn't really matter whether you're talking undergrad or grad. What's the more common sort of situation out in the business world? Doing analytics, doing fintech, is it changing? And how much can you stuff into one degree? So when we made the decision to go with our undergrad curriculum being based on Python, see if I can back these up and talk about them one at a time. So first of all, to be quite honest, another, I feel, hidden benefit is that the way that R is interpreted means that it's sort of better suited for having a nanny-like IDE that helps you out, that offers prompts, right? It's not so much you need to get it right and then the compiler will kick out errors. As you're typing stuff in, RStudio is sort of hovering over you and trying to help you out and fill in the blanks. It's not well suited for things that are going to be done again and again. That is, again, as we said, you're not really going to be making R scripts that you're going to run on a command line, just point it at a new set of the data and say, run the same darn thing. Most students, when they run R, are going to launch RStudio, load the script, run the program, get the results, and then do with them what they will. So I won't say it's laziness, but when you're teaching, particularly business students that are new to coding, R provides sort of more support, and the IDE for R provides more support. Now, the other, like I've already noted, is that, there's really only one game in town for R, and that's RStudio. The problem I find, it's not really a problem, it's sort of a side effect of one of the benefits of Python. There's a lot of IDEs out there. There's IDEs that are designed simply for doing analytics, right? Spider walks and talks a heck of a lot like RStudio. There's a couple of other interfaces that look even closer to RStudio, but there's also interfaces that are really more focused on the whole compiling, getting a command line version ready. And what you see in different classes is usually a choice of the instructor, and they usually make a good choice based, again, though, on the fact that you're normally talking about more advanced coding classes. And even if students haven't maybe had a class in Python, they've at least had a class in something, and it's easier to learn a second language once you know a first. The other thing, and something that we see with Python is, the whole, we froze the 2 implementation versus the 3 implementation. Now going forward, I think Python has announced that they're going to be, I think, doing away with the old 2 implementations, and that'll make it a little bit bigger too. But I think one of the reasons that the Python 2 implementations stayed around as long as they did was, basically grandfathered code that was being used out at a lot of businesses. They had lots of bodies of code that they understood it was going to be a mess and a big effort in order to update them to Python 3. Whatever. And then finally, I'll be quite honest, inertia. Like I said, in our particular case, we were already teaching the analytics core in R, and so it just made sense, or would allow us to leverage a common knowledge base throughout the curriculum to design. If you're getting an undergrad degree in business analytics, R is going to be your main tool. But as you've correctly noted, R is not suitable really for fintech. But is Python the best thing? Because we've also heard, right, well, actually, if you really want to do algorithmic trading or something really, really fast, the final code needs to be in C++. So then we're faced with a question, given that, in my feeling, one, who does fintech, right? Think about the name. We're talking mostly finance, but it is spreading to other places, right? You've got insurtech, you've got marketing tech in some sense and things like that. But for right now, it's the finance students primarily. While on the other hand, anybody can use analytics. And analytics, my view of things, because I was a consultant in the late 90s, early 2000s in the banking in the large banks. When Basel Accord hit, they were driven because of Sarbanes-Oxley and other regulations to start keeping track of things in a systematic way, multiple times a day, and then acting on it. I think over time that's evolved more to where the computer is doing some of the acting on it for you. But at the time, the state of the art was really sort of an analytics project. So one could argue that high-tech analytics got started late 90s, early 2000s. And at this point, 20 years later, it's now spread into just about all other industries. Fintech, as we got stronger computers, started a little bit later. It's still primarily in the finance industry, but we're also seeing some of the models, some of the tools, right? AI, for instance, in cars and so forth, spreading into other industries. So right now, the point of time that we're at in terms of what the typical, particularly business student needs versus what the typical fintech entrepreneur involved person needs, there's a discrepancy there. I still think that this is the right time to be teaching the broadest base R, because the focus of the broadest base is going to be analytics. For specialized programs, that means that you have to then go back and ask them to add Python or add C++ or add both. And, you know, the problem we're going to see, and we've already struggled with this in the business school, when you add R, where does it go? Well, we shoehorned it in with 1.5 credit classes. That little 044 and the 244 for visualization are not full classes the way we normally think of them. But even there, now we're struggling with how do we keep teaching both R and Excel? If we tried to go back and say, okay, you know, and everybody, at some point, I guess we'll get there, but if everybody needs to know Python and everybody needs to know C++, you can't do that. There's simply not enough space in the curriculum. That CSB program, that Joint Computer Science and Business undergraduate degree, typical undergraduate degrees have what, about 124 credit hours. We had to put 136 in. And I will say that the CSB undergraduates, of all the undergraduates we've got, probably get the deepest steeping, if you will, in things like Python, C++, making programs that are going to continually run on your behalf and so forth.
Troy, actually you started something because somebody had asked a very interesting question, and both Hank and Charles actually kind of answered. I don't know if you see it in the Q&A, but one thing I have to say is that in our program, we don't teach anything. We don't teach coding languages. I mean, you could use R, you could use MATLAB, you could use Python. So there's not a focus on actually teaching you the coding the way you have it in the other programs. But the fact is, at some point, don't we have to choose? Because I mean, Charles said, well, it'd be nice if you know both R and Python. I mean, sure, but is that actually doable?
I don't think in any degree.
And I understand from one of my students, and I forgot the name of that language, but he says actually there's a new language that's coming out. And he's over at on the West Coast at Fisher Scientific, and he's saying, you know, they're using a new package, a totally different package now. So what do we do, Troy?
Well, I think the biggest problem we've got is, one, you're right, we don't teach languages, right? If you think about it, most courses that I listed for the undergrad curriculum or whatever, there's nothing in the course that says this course teaches you R. It says this course teaches you how to get data, clean data, visualize data. And so it is a choice. But when you're talking about curriculum programs, the same way companies standardize on tool sets that they use and that they're going to adopt for things, colleges and degree programs have to standardize to some extent on languages. Whether they standardize on one or two languages, that's a hard call to make. The point that I was making right before you pointed out that there had been Q&A, which I can't see anymore, by the way, was that it was all we could do to stuff one language into our curriculum. And I still deeply feel, particularly if you're talking about undergrads, but in some cases, even masters, right? Because we have master's programs that are designed to be completed fairly quickly. Can you put in two? Yes, but it needs to be thought out. It needs to be intelligent, and you need resources to help them learn the language. You can't expect students to start courses and all of a sudden, okay, we're using this. Here's the code. Because if you do, it's like 30 years ago when people first started to use Excel in teaching. What was the inclusion of Excel in a course? They give you a blank spreadsheet with the words filled out, and it was your job to type in the numbers. It was a template, right? And nobody learns to make an Excel spreadsheet doing that. You have to sort of start with basics. And let's be honest, someplace in this whole process, you're going to have a point or points where students learn the basics. Now, hopefully after they learn that first one, they switch over to the second one. Is the segue going to be seamless? Is it going to be fast? Will it help them that they know the first one to learn the second? I would hope so. But I'll be quite honest. Let me go through the three questions and then I'll sort of summarize the point because I know I'm really short on
I
time.
think you're
here.
running out of time. We have to kind of close it. But go
Yeah.
ahead.
So what's the difference between fintech and data analytics? Well, it has a different focus. Data analytics, you're, like I said, producing something for a human to use. It's a slow and stately process in many cases. And it's a human intensive process, right? You're making a process where the human does the work. In fintech, it's a process to create a process. It's a process by humans, but to create usually a standalone computer or computer program that's going to do something for you. And so the time speed that humans act in, having fast code in R versus or slow code in R versus fast code in a human doing analytics using C++, the difference in speed doesn't make a lot of difference. Computers are getting faster, quicker and quicker. But in terms of when you have a computer doing it, if you want them to monitor it continuously, and if you want them to react quickly, it does matter. So the point here is that it's different use cases, but it's also, because of that, different needs, and those different needs wind up driving different skill sets. I think that going forward, we will see over time more universities trying to push Python into curriculum. Right now, though, most universities can't push anything into curriculum. Lehigh is, and this isn't just a banner ad for Lehigh. I think Lehigh is a lot ahead of the curve on this. When I talk to AA CSP accreditors or ABET accreditors on the computer science side, they're like, yeah, we've never heard of somebody trying to, combine programs or have such a sort of comprehensive introduction into these career fields that we do. So I think that best case, we've made the decision right now for R for the undergrads, a mixture of R and Python in many cases for our grads.